everybody, and welcome to this presentation on arming yourself with domain-driven security. It's time to slay some security trolls. We are Daniel Deogun, Johnsson, both of Omega Point, company with a few sites and offices around Sweden, one of them here in beautiful Gothenburg. Google us if you want to know more about it. Should you fall asleep or need to leave, we think let's start with the key takeaways. And if this seems like buzzword bingo, it is. We'll run the same at the end of the show, and hopefully you can cross out a little bit more of the buzzwords. So, domain-driven security helps to design secure software without actively thinking about security all the time. We can treat injection flaws as a modeling problem rather than validation problem. We can use context mappings, and those are essential to avoid cross-site scripting and other second-order injection flaws. And microservices, which is all the fad nowadays, will be scary as hell if we not get a grip on context mapping. So we're going to look at domain-driven design from 4 different perspectives: simple attacks, technical attacks, and simple setting or complex setting. So, Daniel, can you give us an example of a simple domain attack?
Sure. Let's call this a company X. We're not supposed to reveal which company it is. And let's pretend that we're selling books, just to make sure that we don't say what they actually sold. And it turns out that one of our engineers were able to inject a negative amount of books in their shopping basket. And that wasn't the real surprise. The surprise was really when finance came down the other day and said, you know what, is somebody called Joe Tester in this team? Because I have a credit invoice. And the funny thing is that the address is really our headquarters address, and we don't know how to process this. We're supposed to pay out this money.
So this was actually in the production system?
Oh, yes, of course, yeah. And that made it really, really scary because this has been going on for a long time. Somebody could apparently give themselves a, let's say, unlimited discount in their purchases, right?
So the reason it showed up was that the total sum...
Well, yeah. I mean, the total sum was negative all suddenly, and that made it so they should credit this money somewhere.
Okay, and had it not been negative, then they just got a silent discount.
Yeah,
that sounds like a pretty awkward business integrity problem.
Oh yeah.
What's the solution?
Well, of course, if you look at the OWASP guide, you all know about the OWASP, and they claim that, of course, you should validate your input, and if it's not valid, you should reject it.
Sounds like a decent advice.
Right, but that's almost saying like, if you fall into the water, you need to swim. And that's not so easy. And of course, this also promotes that you separate your validation from your data. And that can show up in a lot of other problems, right? I mean, you start creating your common libraries, common util packages, where you say, hey, I have the same validation here, same validation there, and so on, and you need to keep that in sync.
So what's wrong with a common validation library?
Well, then you're going to get dependencies, of course. That's really awkward, and you get this monolithic mess. So, yeah. Okay,
so in that case, what domain-driven design's got to say about it?
Well, the DDD approach is a little bit different. First of all, the analysis that we can do is that first of all, that -1 is somehow modeled as an integer, or at least treated just as an integer. And apparently, this concept of a quantity is an implicit concept in this particular application. And it's probably because the business analyst or domain expert said, you know what, I want to be able to buy books. Okay? And I don't want to buy 1.5 book. I want to be buying whole numbered books. And the developer goes like, yeah, this is an integer, right?
Yeah, I hear that you're stressing this implicit model as if it was something bad. What's the DDD solution, domain-driven design solution?
Well, I think we should model this or look at this as two different contexts. In the first context, you enter a -1. And in that context, that's just a number. But in the application, we need to map this and represent this as a quantity. And a quantity is something different than it is from a number, so to say.
Okay, sounds okay. So what does the code look like?
Well, an example of that would, of course, be like this. Let's see here, you can see that you have a quantity, right? It takes that int value, and it has a contract, a requirement on it, says it has to be greater than 0. Apparently, the developer has been talking to the domain expert and say, you know what, I'm not going to accept quantities that are 0 or less.
So this is a immutable, good old-fashioned value object class.
Oh, yes, absolutely.
So you said that talking about the negative amount was a good start.
Uh-huh. And that is actually very interesting, because when you start doing this, you are entering a discussion with your domain experts, because now, as you can see here, what's the upper bound? Is it 2 billion
2 billion
books?
Max int, 2 billion books. That's a cater of books.
It's a pretty big shopping cart, and I can just imagine what shipping will do.
So would that be a sane thing?
Probably not. And that's the thing. When you start doing this, you're going to bring this to your business analyst and go, hey, what's the upper bound? How many books should it be allowed to purchase?
Is it 10 or is it 100 or?
Yeah, what's a reasonable amount?
If we apply this, where does that take us in the long run?
Well, in the long run, you are going to create a big library of, let's call them domain primitives. So you actually consolidate your business rules, and you create these building blocks that sort of defines your business. And that sort of raises the floors of your APIs.
Well, that sounds nice.
Mm-hmm. So as you can see there, you don't accept a string and an int, you accept an ISBN and a quantity. So it's just really as simple as that, I think.
But, okay. No, is it really this simple? I don't think so. I mean, let's take another example. If we look at this, we're trying to go from strings and int to ISBNs and quantities. Let's say we got an email address.
Mm-hmm. Yeah, I mean, that makes perfect sense.
Yep, sure. So then we would have something that looks like this, an immutable class where the email address is a string which is wrapped, and then we just check out.
Oh, wait a minute. What do you mean? But check,
we just check if it's a correct email address.
What is a correct email address, really?
Well, hey, there's a Anyone read the specification? Yeah, RFC 5322 section 3.4, address specification. And they give some examples where it's pretty vast. And actually some of these are okay email addresses. And we can craft a regex. No one has managed to make a complete regex, but that's some good attempts. Here's a regex that covers large portion of the specification. It's just 6,000 characters.
This is insane. Are you saying that I just put this in my constructor? It doesn't make sense.
A 6K regex?
Yeah, no.
No, sure. No, that would be bizarre. That would truly be bizarre. Mm-hmm. So we need to do something else. Of course, we do not need to accept email addresses, all email addresses that are allowed by the specification. We need to accept the email addresses that make sense to us in our domain. For example, we probably do not want root 127.001 as a customer email address. So instead, we turn it inside out and start talking about what email addresses we want to accept. For example, Daniel, Deogun, omegapoint.se, and other that follow a similar pattern. We make a regex or two, or a short validation, and
Okay.
Keep it simple.
So this makes sense, but is this domain-driven security then? Is that what you're talking about?
This is kind of like the starting point of domain-driven security, talking about how we could bring domain-driven design practices, which we just consider as good coding practices. And by thinking about those, we at the same time solve or avoid security issues. So in 2009, it was phrased by me and John Wilander, Dr. John Wilander, that domain-driven security is about taking ideas from domain-driven design, using them as tools to address security concerns. Tools, ideas, mindsets, even though those tools were not originally designed specifically for security issues. So that was kind of the starting point, but Daniel, that was 2009. Has anything happened since then?
Well, believe it or not, Dan, time flies, things evolve. And of course, the interesting part is really what happened after 2009, when we started to conceptualize and utilize the ideas that they came up with into industry practice. And I've been involved in several projects. I've looked at other projects, and without showing any numbers, we have significantly reduced the number of security flaws that are at least found.
So what do you mean with significantly?
I mean, the funny thing is that we have examples where you have a and B test. They've written one system, and they found so many security issues that they decided to terminate that project and redo it. And that's when we came in, and so we said, let's apply these principles, this mindset, and we do pen tests on both of these. And in the second one, they've come up with, like, I don't know, 2, 3 problems, and we of course address them.
In the second attempt, did the people think about security all the time, like let's avoid OWASP?
That's funny. The thing is that they're not security specialists at all. They're regular developers. Yeah, I mean, they want like good design. They use DDSec, of course, and they use other, good design principles along with that. And by that way, they have successfully designed a system that it's more secure than other systems, I guess.
That's a good thing, because I've found that developers in general hasn't got the time to actively think about security all the time, because there are features to be implemented. So, nice. But are there anything more to domain-driven security apart from this history timeline?
Well, I certainly hope so, because otherwise you have to terminate this talk right now. And what we just looked at was the simple domain attack. But there's, of course, a lot of technical aspects in a single system. I mean, what if you attack the actual technical construction and technical design of a system? I wonder how DDSec could help us there. So can you please tell me some more about those technical attacks?
Well, the technical attacks, as opposed to domain attacks, attempt to attack the system by technical means and often with a technical objective, like root access to the service. And the injection flaws are the most famous of those. Injection flaw, you use some kind of data that is maliciously crafted and that tricks the system into interpreting those data, not as data, but rather as code, and do something nasty about them. The classical example is, of course, the dynamic SQL string attack, SQL injection.
But you probably know about this, all right? Yeah. I mean, SQL injection.
Yeah, so you send in or1 equals 1 dash dash, and then suddenly this where clause matches all the rows in the database, and you probably get admin access. Right.
So what's DDSec's take on this then?
Well, this is we can apply the same mindset as we did with the domain attacks. Right. Or1 equals 1 is not a valid username. So we would model our realm of usernames, and we will have a constructor which only allows those we consider real usernames.
But that's my middle name. I like that username.
Okay, then we will have to have domain discussion whether this should be allowed inside in the domain or not. And if we decide that it is something that is reasonable to have inside domain, then we will have to take other means to ensure that this is not mapped to code.
Okay, I get it. It's sort of like the email address. You sort of make your domain specific. You say, I'm not going to accept anything. I'm just going to make sure that I accept what I want.
Yeah. And then on the inside, we need to, if we let that kind of data in, we need to protect us. But let's get back to that later. But that's kind of a complex.
But Dan, anytime I Google SQL injection, I just find prepared statements. Should I just throw those away now, or?
Oh, no. Don't get me wrong.
Okay.
Prepared statements are the golden way to address SQL injection, or parameterized queries if you haven't got SQL but have something else. So that is definitely the way to address SQL injection. But SQL injection is just an example of the more general injection flaw. In some situations, you have a query structure that is dynamic, or you do not have prepared statements. If you got LDAP, well, you can have LDAP prepared statements. If you got command lines you put together, then you got command injection if you're not careful. If you're using XPath, you can have XPath injection. If you involve HTTP headers, you can have HTTP header injection.
Wait a minute, HTTP header attacks?
Yep, you can attack.
What's that?
You can attack a HTTP response by attacking the headers. For example, you might have something that looks like this. You have a cookie, which is your favorite author, and that cookie is set by picking out something from the user settings.
Okay, I mean, this looks sound. I mean, how can you attack this?
Yeah, you see here, the cookie is actually terminated by the line feed.
Oh, wow.
And then we've got the content, which is how a HTTP response looks like. So if you craft a more interesting author, while/hacker/r/n HTTP, then the cookie value will be inserted into the response stream, pushing the real content in front of it. So what the response ends up with is actually the hacked content, and that is what will be visualized on the poor end user screen.
I see what you're saying, but
try to prepare statement your way out of this.
Yeah, but this is really a violation of the specification, isn't it?
Oh yes, definitely, right. And that's the kind of point of it. We are crafting an attack that violates the specification. And of course, we can read the specification. And it says there's a control line field, and that's the problem. We're pushing ourselves out of the headers and into the message body. And as I see it, there could be two ways to protect this. Either we as application developers must ensure that the cookie value, the author, cannot contain these characters that will violate specification. And that is actually what we should resort to doing.
Okay.
But we can also shift some blame.
We could shift some blame to the API design,
yeah,
right? Yeah,
because I mean, a sound API design would have an API that does not allow calls that violate the underlying specification. That should be a good API design. So the JAVAX servlet cookie API should protect itself and not allowing data that will end up in this kind of tech.
All right, so this is really not a specification flaw.
It's not our fault.
No, it's not a specification flaw then. Okay, good.
Or perhaps partly. So, but what could the domain-driven security do to help us with injection flaws in general, if we look back on it?
Well, if you look back on it, I mean, you can really tell that DDD in itself, that mindset really helps us from separated data from code. I mean, that's really what it's all about, right? I mean, we have to understand what we are doing, okay? And then it comes to the validation part. And in difference from OWASP, what we are saying here is that we should validate with respect to the model of your business.
You're once again putting a lot of stress on that model.
Right.
So does validation make sense without a model?
Well, I guess it could potentially, but you don't really know what you should validate somehow. I mean, it doesn't add up, I think.
Okay, so this validation seems pretty crucial. So, in practice, how do we validate? Is it just regexps?
Well, you may think so, but actually John Wilander came up with a pretty good strategy for this. And the first thing you need to make sure is that whoever sends you that data is somebody you want data from, right? So the origin of that data. You should also make sure that the length of something makes sense, right?
Why?
I mean, I don't know, a 2 billion character long username is probably not sane.
That's probably the DOS attack, yeah.
So you probably don't want that. And then, of course, you need to make sure that what are the characters in there? I mean, should a first name contain digits? Does it make sense? No. In our world, no. And then, of course, you need to make sure that the structure of that data is correct, especially if you have XML, right?
Oh, yeah.
Yeah, I mean, some of you may have heard of the billion laughs attack or XSS attack.
That sounds intriguing.
Yeah, when you start parsing the XML entities, you can make things blow up from a really, really small contents.
So a really small string can actually expand to a billion lols?
Yes.
You should Google that.
Yeah.
Billion lol attack.
It's very funny, so yeah, makes you laugh. And of course, the semantics. Does it make sense to get this data at this point?
Okay, I see that there's a point in this order. You should not parse something unless you check that it's less than a gigabyte.
Right.
Yeah.
So then, what about complex attacks?
Yeah, let's proceed. So the complex attacks, now we're moving from the simple attacks to the complex attacks. Complex attacks are when there's actually no fault in a single system. But what we're attacking is the system of systems. So we're trying to find ways where we go through one system to the next system, and then they misunderstand each other, causing some kind of vulnerability.
So what does domain-driven design say about this then?
Well, the major tool we got in the DDD toolbox is the context maps, context mapping.
That's a strategic design pattern,
yeah,
right?
That's a strategic design pattern.
Okay.
So it acknowledged that if we got a large system, we do not have one single domain. We probably have subsystem, and each subsystem is a domain or a context of its own. For example, we got the purchase system where we have order where we purchase stuff. We have a logistics system where the stuff of the order is moved around. We got the finance system where the order is put into bookkeeping. And those three are, well, they got the same name, but they are not the same concept. Because here we got stuff that are not relevant over here or over here. So there are different concepts.
I mean, I see this from a DDD point of view, that we are traveling across boundaries and this order travels there. But really, Dan, what does this have to do with, technical complex attacks?
Yep. What we keep in mind is that we're mapping from one context to another. And keep that in mind, and we'll talk about cross-site scripting, which in our analysis is a complex technical attack. So, cross-site scripting is where we take some untrusted data and feed it from one browser into the system, and then the content is delivered to another browser. And in that browser, it is interpreted as code and suddenly run on the victim's browser.
Okay, that's kind of, I don't know.
That's
kind of lost me there a little bit.
That's not really clear.
Yeah, okay.
Can we demo this?
Yeah, okay. Let's demo it. We're going to use an application written by one of our colleagues. He has a beautiful first name, Daniel, and it's Hultquist. We have a really bad entropy when it comes to names at Omega Point, I guess. Daniels, yeah. And this app is intentionally, how should I say, weak.
So this is actually available on GitHub.
Oh, that's my family, I guess.
Nice family
Can
picture.
I move this? Oh yeah, there we go.
This application is actually available on GitHub. It's a public repo, Omega Point /facepalm. If you want to sit down and lab with it or showcase it in other areas, feel free to do so. of course, the source code is there, so you can see it contains examples of SQL injection, command injection, etc.
That's a lot of stuff.
So,
okay, I just logged in. The funny thing is I can't see it on my screen, so I have to look over there. And I'm going to do a cross-site scripting attack, of course. It's very easy. So I'm going to place a comment. Let's see if I can move the pointer there. And I think I had something in memory.
This part is content and should be shown up as content in the poor victim's browser.
Yeah, so what's the meaning of life? And then it's a little script. Press enter. I guess not. I need to somehow press that button.
So now it will be re-rendered, and actually it is executed as code.
Yeah. So of course you're going to ask yourself, I mean, is this really a problem? It's just a pop-up, but honestly, you can take over your entire system. It's game over.
It could be installing a keylogger.
Yeah.
Could be doing a support scan, and then sending the result over to some site in another country outside our jurisdiction.
There we go. Let's go back and see if I can press play. Here we go. Yeah, we see stuff. Good.
Yep.
So, what does this mean from a context mapping perspective then?
Okay, so then if we get back to our domain perspective, so our technical analysis of this is that we've got three domains: the domain of the sending browser, the domain of the server, and the domain of the browser. And we should be aware of that we are actually moving the same piece of text from being text visualized in the browser to being something we regard as a comment on the server side, and then mapped over to what is text in the browser.
Okay, so what's the problem with that?
Yeah, the problem is that in the browser we've got more concepts than text. We have text and code. Mm-hmm. And what we have is that the comment is not mapped soundly to the text. It's mapped, a broken mapping mapped onto code. So the browser interprets running something it should run.
Okay, I mean, I see your point here, but what's the DDSec solution on this then?
Well, looking at from this perspective, it becomes pretty clear that we should not store it HTML encoded on the server or something like that. But the problem is actually in the transfer. So instead we should apply a proper encoding, making the context mapping, fixing the broken game mapping.
Okay, so I see your point here is that by using a context mapping tool, we are able to realize as developers that we are traveling, the data is traveling across semantic barriers.
Yeah.
Right?
So, Daniel, could you compare this to the injection flaw?
All right, let's do that. I mean, you can draw it like this if you want to.
That's a stack, I guess.
Here on the left, you have a SQL injection, and there on the right, you have the cross-site scripting.
Yeah,
and I mean, they're the same.
No, they're not.
Yeah, I mean, see, that's a red arrow, and that's it.
You claim these are the same?
Yeah.
Not to me.
Okay.
Could you draw them in some other way?
Let me clarify this then. Let me draw this as a hexagonal architecture with hexagonal.
If it suits you, sure.
Okay, in a hexagonal architecture, we have ins and outs, right? And now you're starting to see.
Not up and down.
Not up and downs.
But in and out, okay.
Right, so as you can see there, you have your SQL injection traveling across your barriers, your contexts. And now if I flip that, like that, we all suddenly get that cross-site scripting.
Okay, so the problem in SQL injection is when you're crossing the border to the database subsystem. Okay, and the problem here is when you're crossing over to the other browser?
It's just a matter of doing that mapping, right?
I can see that this shines some light on understanding cross-site scripting. Does this help to understand the other complex attacks? Because I guess there are more complex attacks than
I mean,
cross-site scripting.
That's a common attack, but it's not the worst one, of course. I mean, there are other attacks, and those are the ones that I'm really scared of, is really the second-order injection attacks. The second-order injection attacks are not targeting the primary system, but rather a secondary system. So in this case here, I mean, an example of that would be, let's say somebody writes a script and they try to log in with a particular bad username, and eventually that system is going to go like, you know what, somebody's been trying to log in with this username 1,000,000 times. Just log that. Somebody's doing some funky stuff.
Okay, so what bad could that be?
Well, as it turns out, the admin tool that has admin privileges is written in Python. And it turns out that bad username was actually Python code. So now you see what's happening, right?
So it's a designed bomb.
Yeah, it sort of gets into the log. The admin tool interprets that log. And of course, you have the same kind of problem with the cross-site scripting there, that suddenly gets processed and executed in the admin tool. And all suddenly, you're being
So what kind of privileges does the log admin?
Well, I mean, can you run it with anything else than root?
Sure, probably.
Yeah. So that's the thing.
Yeah, that sounds scary.
Yeah, but are there any other patterns that we can actually use?
Yeah, for this kind of things where we want, we see that we've got some sensitive data that we'd not want to see leaked elsewhere. It could be a password, it could be a credit card number. We can model our way out of a lot of those problems by acknowledging that this data is sensitive. And this is a coding pattern was suggested by Daniel Savano.
Yeah, that was the guy I talked with.
Who was presenting here yesterday.
Yeah.
Where we design a sensitive value object so that it could be read only once. When it is read, it actually nulls out itself, and if you try to read it afterwards, it will just not give a proper response. Meaning that if this object is inadvertently used somewhere else on the route to where it should be used, then it will go BAM.
So you're basically saying that we're probably going to detect this kind of problem in our delivery pipeline.
Yeah, probably we will detect this because our tests will fail.
Hopefully at least.
So when someone inadvertently added this to logging, that will make our
So this is a good pattern then for somehow adding a little more chance to detection, so to say. Right.
Definitely.
Okay. So can you please sum up now what DDD6 says about these technical attacks?
Looking back at the complex attacks this far, we saw that domain-driven design and context mapping gave us a deeper insight in the nature of cross-site scripting and thus allowed us to detect possible broken maps. So, and also that modeling confidentiality, for example, can help us avoid data leakage, second-order attacks, etc.
Okay, but that's fantastic. Now I'm all pumped up because now I'm so interested in those complex domain attacks, right?
Yeah, complex domain attacks. So now we're moving into the realm where we're talking about complex attacks, attacking a system of system, but not on the technical side, but we're attacking the domain integrity. Daniel, can you give an example of a complex domain attack?
Okay, well, let's bring back the same old introductory example of that bookstore. Of course, what we said, we had that -1. Suddenly it came to finance. Finance, they created this credit invoice.
Okay, so what other systems did the -1 send
well,
to?
Of course, it came to storage, and we all know what you happen to get a negative amount of books in storage. That means that you're going to add a book.
So they subtract -1, meaning they increase the inventory from 26 to 27.
Right.
Okay.
And then, of course, it gets to shipping. And you know what shipping does with a negative amount to ship? They say, what the F is this? I'm just going to throw an exception, and that gets to that, exception log that nobody really reads.
Okay.
Yeah.
So is this detected immediately?
Most likely not. This is probably going to be, discussed during the yearly inventory, and it's going to be a discussion where people in the storage department are accused of stealing.
Because at the end of the year inventory, they lack a book.
Yeah. And of course, not one book, it's probably hundreds of books, and, well, they're thieves.
So this could go on undetected. Okay, but to really a little bit critical, there's actually a bug in one of these systems. Okay. So can you give an example where none of the systems are broken?
None
but
of the
where
systems.
the entire system is
Okay.
broken.
One thing that is another real world example, and that's actually an insurance company. And they started out like we all do with that big monolith, right? And microservices just came to be the popular thing, the new silver bullet. So
what did they do?
well, of course they decided to, microservices it. So they split that up.
So the purchasing people were looking at the purchasing system and the insurance people were looking at, and the payment was sent to payment. Makes sense.
Makes sense.
So
And this worked beautifully. And
did they have separate teams?
yeah, of course.
Okay.
They
So
could
they split the
parallel
team.
things. Yeah, split the teams, and there were different sites, all that stuff.
That sounds like a good. When did the problem start
Well,
arriving?
the problem really came up when, business came up with this great idea, or sales, or whoever it was, that, you know what, we should allow gyro payments.
Through banking.
Exactly.
Okay.
And so what they did is that some customers wanted to be able to pay this way, and in order to do this, they added a separate context, or another microservice, of course. They called it, the bank one. And as soon as you got your payment, the payment got over to insurance. The insurance letter came out, and
Okay, so gyro payment, when the payment was made, sent to the bank, they considered that's a payment, and then they waited for the confirm or reject. So in what situation did this design looks fine? When did it break down?
It's funny when you say that. The trouble really came when they, well, first they didn't realize this. It was that, as you can see here, we've decided to only add this as a, one of the main reasons when you do microservices is, of course, to say we can do surgical precision changes without affecting anything else.
With surgical, you mean you change one single system?
Yeah,
one single
tiny thing.
I've read that. It sounds like an excellent idea.
Right, and the thing was that they kept, payment as their way of communicating to insurance and saying this has been paid.
Yeah, why should they change that? They would have broken the downstream dependencies, and the insurance guys would be really pissed.
It wouldn't have been a small change then. It would be a bigger change, of course. So the problem here is that if you look at this, it's really that a payment is no longer just a payment. Whenever you get your confirm or reject from that bank, that's when you need to issue a gyro payment. And now is the time when you should actually send this to insurance and say, it's been paid.
Okay, so if you let me just go back last slide and see if I can reiterate that.
Right.
So the problem is that as long as our payments go through, we get a payment, it's sent to the bank, and the policy is prolonged.
Yes.
However, when a gyro payment is rejected, well, then we just keep it as a gyro bounce.
That's right.
But the payment, which was sent to the bank, has already resulted in a prolonged. Okay.
In a nutshell, you can say it. They send that payment notification a bit too early, right?
Yeah. So your point is that they should have separated that payment is no longer one concept. It's actually two different concepts.
But that would have, of course, involved the other team, and that could have rippled to other teams and other teams, because the reason why we didn't do this is, of course, of that surgical precision thing.
Okay, so I can see that this surgical precision change, which we did, we should have done this. But then it should have gotten awkward, and instead we did the simple solution.
Right.
But this is just 3 systems. What if we had not 3 services, but 300 services?
well, Dan, that's funny. I couldn't fit those 300 on this slide. So that's the thing. In a real microservice architectural system, you're going to have like 300 plus services probably. It's a bigger one. And then it's going to be really tough to actually look at them, and then when you're actually going to get a microservice hell. Because now nobody really has the big picture unless you can guarantee that you do a correct context mapping between all these. You need to realize how things are related, how data flows, what's the business rules around this.
So you mean that when we make these surgical precision changes, we need not only the people involved, but also the people in the adjacent systems?
Exactly.
And,
I mean,
and not only the tech people, but also the business people?
The business people, of course.
Will that be possible?
I mean, it should. I mean, that's really, really important. Otherwise, you're in big trouble. So,
otherwise, well, I can see
so
that.
can you please just sum this up now?
Yeah, we've been looking at vulnerabilities and attack vectors from 4 different perspectives. Simple domain, just attacking one simple system using a domain attack. We've been looking at attacking a single system from a technical perspective. Complex technical attacks where we actually attack the system of systems, but from a technical perspective, cross-site scripting and second-order injection. And then finished up the kind of contemporary thinking about this, which is the complex domain attacks, where we attack a system of systems.
Wow, so now actually the key takeaways is probably going to make sense.
Yeah, sure. Let's now bring out the buzzword bingo again. So domain-driven security helps one to design secure software without actively thinking about security all the time. Do we need to think about security sometimes?
I mean, of course, a little bit, but not much. I mean, you have to do your context mapping, and you need to do your validation, map your input to your domain objects, right? Make your domain primitives, all that.
And from time to time, we should do our pen testing. Of course, from time to time, we should do our security audits. But we can get a lot of that stuff by just our day-to-day thinking about good design. OK, so we can treat injection flaws as a modeling problem rather than a validation problem. To do context mapping is essential to avoid cross-site scripting and other kinds of second-order attacks. And finally, microservices, they will be scary as hell. I mean, because we're all pro microservices.
Exactly. I mean, we're not against microservices at all. We like it.
But we must be aware that unless we get a grip on context mapping, they might run totally out of hands.
Right. So I think we have like 3 minutes left.
Yeah,
so
sure.
let's bring in some Q&A.
Any questions or comments?
Or yes, there's one.
Please.
Has there been any resistance against having domain-driven security involved in a new project, or is it only after they got scared hands out of it?
Let me just repeat the question. Has there been any resistance to bringing domain-driven security into the projects?
Well, it's funny. In some of my projects, there have been resistance against domain-driven design. They go like, yeah, this is so expensive, we can't really do this, right? Modeling takes forever, and so on and so on. Business needs to be involved. And
which is bizarre, because we actually do modeling to speed us up.
Yeah.
Not to make something that is good in the long run, but actually to speed us up now, in this sprint.
Right.
Nevertheless, it's perceived as taking a lot of time.
But when you say, when you in this discussion, they say, well, we have these security problems that we found during this last pen test. And I go, you want to address them? Yes, we do. OK, our method of doing that is domain-driven security. They go like, what? OK.
The sell is a lot easier.
Yeah, it's a lot easier to get a buy-in from that end somehow. And it's really, you're doing DDD, and you're applying these patterns and so on. And it's pretty nice.
Yeah.
Yeah, of course, it's like insurance. Should I buy insurance or not?
You need the awareness first.
Should I wear a helmet? I don't know. Yeah.
In that case, thanks a lot for your attention. And I think we're heading for lunch, which is provided by Solid Beans. There will be beans for lunch.
Solid
obviously.
ones.
Solid beans. And thank you for your attention.
Thank you.